Hey there and welcome back to the Code Wrinkles channel for a brand new video in the ASP.NET Core Web API with CQRS series. And remember, in this series we just tried to lay out on how to create a basic but very powerful Web API in ASP.NET Core using CQRS. And we have covered a fair amount of ground till now, and it's time actually to move one step forward. In the previous video, we have implemented a full CRUD REST endpoint using a product service, which we see here, which is actually just an in-memory service that for now we actually hold in our API layer, which of course is not convenient. But we just wanted to use it in order to implement this whole concept of CRUD endpoints in an API controller. So in this video, it's time to actually move one step further and add Entity Framework Core and store actually our products for now in a database and start working actually with real data. So let's get started with it. What we need to do is actually, or contains actually two very important parts. So the first part and the first thing that we need to do is install the necessary NuGet packages. Now, the important thing here to note is that we have chosen to actually also layer or create layers for our different concerns that we have in our API. So unlike in most tutorials that you would see online when it comes to web APIs where everything is actually packed in one single project, I really like to keep things as close as possible to what we do actually in a regular production ready web API. And that's why we have these regular layers that we have when we have CQRS, like we have the domain layer and we have a data access layer and we have an application layer, which we have not touched so far. So in this one, we will have actually to go over to our data access layer and add something there, and also in our API layer to actually make it work with the database. So let's start first with this very basic data access layer that we have here on the right, and we see that it is an empty project. Now let's just here go on dependencies and on manage NuGet packages. Now here, one important thing that we would have to note is actually the version of ASP.NET Core that we are using in our API layer. And as we can see here, we have this program.cs class only, so no startup, which means that we are currently in .NET 6. Which means that when we install Entity Framework Core, so if we go here on Browse, let me also change the feed to NuGet, and let's search for Microsoft Entity Framework Core. Now, when this refreshes, we'll see that we can actually here choose which version to install. Now, of course, as we have a running ASP.NET Core on .NET 6 API, for us, it's okay and convenient to just use here the first one. But if you're using a previous version of .NET Core, like for instance .NET 5 or ASP.NET Core 3.1, then go here in this list and navigate to the version that you are actually using. So if your ASP.NET Core API is of .NET 5, then you can choose here this version 5.0.13. If your ASP.NET Core Web API is on on .NET Core 3.1, then you have to actually choose this 3.1.22. Now, this being said, for us, it's okay to install this one. So let's just get started with that. I should also get a screen and accept all the licenses that we have here, and this package should now be installed. Now we need some other packages. We also need the package for SQL Server, because we will be using a SQL Server, so let's also install the same version. And for all Entity Framework Core packages, it's actually the same. You have to choose the version that corresponds also to the version of your ASP.NET Core API. Otherwise, you will have a lot of problems and errors and you can't really run it. And there is one other package that we might use, since we might want at a certain point to also customize our DbContext. Then we should install this Microsoft Entity Framework Core tools. And I would also like to install that. And that's actually it for this data access layer. And since we are right now at this installing NuGet packages part, let's go over to our API and do exactly the same. So we go on manage NuGet packages, and here we have to install basically the exact same packages. So Microsoft Entity Framework Core, this is the first one. Once again, 6.0.1 should be okay for us. So let's accept that and install that. Then we have, as said, SQL Server that we need to install. And we'll also have to install Microsoft Entity Framework Core tools in this one, as we might need to configure different things here at a certain point. So let's also install by default. Now, some will argue that you don't need really to install this Microsoft Entity Framework Core tools here in this package, but I usually tend to do it because you will probably use it or need it sooner rather than later. And this being said, everything is done, so we are good to go from this perspective. We have installed all our NuGet packages. So let's move now to the second part. Now, if we want to work with a database, there is something that we need here, and let's add a new class in our data access layer project, and we'll call this DbContext. Now, what we need to do here, of course, this should be public, as we will need it also in the API. We should inherit from a class that comes from Entity Framework Core, which is the DbContext. And the DbContext class is actually, I would say, an in-memory representation of the SQL database. This is actually how Entity Framework Core works. And as we have this set up, there are actually two things that we have to take into considerations here. So first of all, we would need a constructor, and we'll see exactly just in a while why we need this constructor at all. And in this constructor, we need get an instance of DbContext options, and we'll call this options. And of course, we need to pass this to the base class. So that's the very, very important part. Then the other thing that we need here is that we need to add DB sets. So this is a concept which actually this DbContext class uses to represent a certain table from which you actually want to get data, or to which you want to write or edit data. And for this right now, if we look into our models, we have only this product, which has these two properties. That should be okay. So we should add a DB set for products, of course. So that would be public DB set of product, and we'll call this products, because this will also be the name of our table in the database. Of course, we will need to add some usings here, add reference to the domain layer, because that's actually from the domain layer, and that's actually it. So right now, this is a very, very basic DbContext that is already usable, so we can start using it. Now, in order to use it, of course, we need to actually add it to our ASP.NET Core Web API. And in order to do that, of course, we need to set up different things. And let's move over back to our ASP.NET Core Web API. So the first thing that we have to think about when we want to add Entity Framework Core is to actually also provide a connection string for the database, because Entity Framework Core needs to actually know how to connect to our database. And that's why these connection strings are for, which specify exactly the server, the database, and the credentials to which Entity Framework Core should connect. And we have then to specify this, of course, in our app settings, and then read this information and use it. We'll see just in a while how, when we register the DbContext in our application. So let's add here a JSON property, which is called connection strings. And let's add here a property which is called default. And here is where we actually need to add our connection string. So I have already created a database. It's a local Visual Studio database that you get by default. So no matter if you see my connection string, there won't be any security problem, because nobody except from my local network will be able to access this. So I'll just paste it here. So as you can see, this is a very, very basic connection string, and it contains the server name, and it also contains the database name and some other features, or the different settings on how this connection should work can be configured by adding different other properties here. But for now, this should be enough. So that's it. That's a very, very important point. You need, or we need, to add actually this connection string to our app settings file. Now let's go back to our program.cs file, and we know from the second video that we have actually implemented a way to keep our file clean here, and we have moved all service registrations in different registers. So let's go in this registers folder, and here we have, for instance, this MVC register. Now this one actually adds all the things that are related to MVC and the API versioning stuff. So I wouldn't really like to add my connection string here. So what we can do here instead is create a new register. And here we'll add all the different services that we'll probably also need later when we introduce the concept of authentication and identity. We'll add everything then here in this new register. And let's call this DB register. So this will be the class, and it would implement I register. Okay, and we have to implement this interface. And if you don't remember how we did this, please go to the second video, because there we really explain in depth how this works. And it's actually very, very nice, because no matter how many such registers we actually create, they will automatically be registered, or all the services will automatically be registered here. So the first thing that we need here is to actually get the value of the connection string that we have defined in the appsettings.json file. So let's have here this variable var_cs from connection string equals, and here is that why on this register, on these extension methods, we have created them on the web application builder directly and not on the services only, because here we actually need to use this configuration. And here we have this get connection string, and here if we provide a value like default, because this is how we name the property in which we have actually placed our connection string, it will automatically get the connection string. And as we have done this, we can then just go to the next step that is specific to Entity Framework Core and adding Entity Framework Core to an ASP.NET Core Web API. And this is actually registering the Entity Framework Core service. And to do this, we have on this builder services, which is the service collection, and then we have add DbContext. Now, DbContext is a generic method. Add DbContext is generic, so we have to provide the name of our DbContext class, and we have named our DbContext class data context. So we have to also add a reference to the data access layer project, and we should be good to go. However, here is the part where it jumps in the constructor that we have created in our data context, because we have to pass in something. And this would be the DbContext options. And the option that we actually want to configure right now is the connection string that the DbContext should use in order to connect to the database. So in this case, we can come here and we can provide here a very simple lambda. And here we have use SQL server. Here we'll probably need to add also a using statement, Microsoft Entity Framework Core, and we'll have to provide the connection string that we have just read from our configuration file. And that should do it. Right now, we have added our data context to our ASP.NET Core Web API, which is a .NET 6 regular Web API, not a minimal API. Now, this means that what we could do here is we could start working and use this data context in our controller. But before we do that, there is one other step, and which is a very, very important one. Because right now we have added Entity Framework Core, we have added the DbContext, we have created everything that we need in our ASP.NET Core Web API project, so the entry in appsettings.json, and we have added the DbContext to the dependency injection container, which is fine, but we also need to create a database and actually instruct Entity Framework Core how to create a database based on our domain model, in our case on this product class, which is a very, very simple model right now, but it could evolve with the time. So in order to do that, there is this concept of migrations. So whenever you have changed something to your domain model, you need to add actually a migration. A migration is nothing else than a class, as we will see, that Entity Framework Core generates by itself to have a snapshot of the database structure. And then when you run update database, which is the second step, it actually applies all the migrations to the database that were not applied already. So let's get started with that part. To do that, we need to open the package manager console. So if we go here on tools, we have NuGet package manager and we have this package manager console. And now here there is a very important part that we have to think about. Now in our setup, we are using the API. We have a project for the API, but our DbContext and all the Entity Framework Core related stuff will be in the data access layer project. So in this case, we have to make sure that here in this upper part of our package manager console, where we see this name of default project, we should change this to data access layer, because in that project is where we have our DbContext, and in that project we want that Entity Framework Core should create the migrations and everything else that it might need. And to do that is very simple. So let's add the migration. The comment for this in the package manager console is add migration, and then you would have to provide a name. And let's call this initial. That would be the initial migration. So this will actually build your application, and hopefully it builds correctly, because if you have build errors, then you cannot actually run this and it won't be created. And right now it was successful. So we see that the migration was added. And if we take a look into this file, so this is a class that was generated by Entity Framework Core, and it has this up method where it actually provides us with information about things that it will change in the database when this migration will be applied. So even if that might seem a little bit complicated, it's actually very, very straightforward, because here we see that we have a create table, which of course will create a table with the name of products, and it will contain some columns, and it would have the ID, it will have the name, the price, and the available quantity. And then we see here that that table will also have some constraints, and the only constraint that we have right now is that we need, of course, a primary key for our products, which will be the ID. So once again, we didn't have to do anything in our product class to do that. Entity Framework Core peeked into our class and then decided based on conventions that we should use this ID as a primary key. Of course, if you want to override these conventions, we have a dedicated video on how you can do that using configurations. So you might just pause this and go to that video. You can find a link to it in the description of this one and on the screen here in the corner upper right. So you can do that and check that out. But by default, it uses some conventions and it actually gets this ID as a primary key. And in the down method, it contains what happens if we actually want to revert the migration. And in this case, it's simple, a drop table, because it will drop the table that was created here during this up method. Now, after we have checked the migration, and if we think that everything's okay, so this is what we want to create, and in our case it is, the next step is to actually apply this to the database. So when you add the migration, you are just generating this class. You are not actually performing anything on the database. To update the database and perform these changes to the database that we have here in this up method, we have to run this command, which is update database. And this will once again build our application, and it will execute a bunch of SQL statements that we can look into here, but basically it's creating the table. And let's just take a look at it. So if we go here on view, we have SQL Server Object Explorer, and we have this CWK eShop database, and it has some tables, and we see that it has products. So this is the table that was created based on our class. And if we look at columns, we see that it has indeed the ID, name, price, and available quantity, exactly like we would have wanted. Now there is only one other table here, and this is a table that Entity Framework Core creates actually, and it uses to keep track about the migrations that were actually already applied to the database. And if we go here on view data, we will see already this migration initial that was applied to the database. And theoretically, this is how Entity Framework Core really keeps track about, okay, what changes have been performed on the database and what changes not, because any time that we would run update database, it will check if all the migrations in the migrations folder, which is here, are present in this database, and those that are not present here in this table, they will be applied, and then Entity Framework will create entries in this EF migration history. So this is everything, or this is why Entity Framework Core actually needs this table, and it's a very important one. It's also a good practice to not actually play around with this table and change things unless you know 100% exactly what you are doing. But this being said, that's actually done. So right now we see that we also have a running database. So a database that has already the tables, or the table in our case, that we need for our product. Which means that the last step that we would perform right now in this tutorial is, of course, we want to use our new DbContext in our controllers. And in this case, we have this products controller in the v1 folder. And what we'll actually do here, we'll replace this product service with our data context. So we don't need this product service anymore, but we need a data context. And we'll also need to add the using for that. And let's call this context, okay? And the same thing we need to provide in the constructor. We don't need the product service anymore. That's something that we can even delete later, because that was used only to have something to work with until we had a database. So right now we have this DbContext, we have EF Core, we have a SQL database, so we can actually replace that. Cool. So let's go in all these methods one by one. First of all, what we need to do is, well, we need to change everything to be async right now, because as we work with a database, this is an unmanaged connection, and of course it's okay to use async and await here to not just block everything unless or until we actually succeed to perform a certain operation. So instead of returning an iAction result, we'll return a task of iAction result, which is not very complicated to achieve. Now here var products equals, and it's very easy because we can simply say here, for instance, await context products, and we have the products because we have added a DB set that is called product, and that's exactly what this DB set is for. And it also represents in memory our product table. And here, for instance, we can see that, or we can say that we want a toList async. This toList async is also in Microsoft Entity Framework Core, so we have to add it, and that should actually do it. Right now, we should get a list of products. Now, if we go to the next method, this is get product by ID, and here is actually, we can once again, first of all, we have to change this from returning an iAction result to return a task of iAction result. Of course, we need also to mark this with async. We have done that for the previous method. So async task, and here it means that we will need an await. In this case, it's not a product service, but it's our context products, first or default, and we say async. Because Entity Framework Core has an async method for first or default that actually gets your products in our case from the database. And the other part remains the same because we are still reading the ID from the route, which is okay. And if we don't find the product, so if it is null because it's returned first or default, then we just return a not found. Okay, then for create product, here actually what we need to do is simply await. Actually, here's not await, but here there are actually two steps, and that's a very important point, because first of all, we see that right now we don't use DTOs. We'll talk about them in a further video, but right now from the body, we get directly the product, the entire product. So it means that we can just say here products.add, and we can already add the product. However, and this is a very important part, let's also write the next line of code, which is await context save changes async. And here there's a very important point that I would like to emphasize. When you add a product with this line here, this actually doesn't add it to the database. It does add the product to the DB set. So it's fully in memory right now at this step. So no action in the database is performed, no connection to the database is done. Entity Framework Core only talks to the database in these scenarios when you call this save changes async. And the reason why it is like that, because in an operation, you might, for instance, want to add several products one at a time, or you might want to perform other database changes. And in order to avoid to actually create a connection and run each change one by one, you can actually add everything to the DbContext, because everything is tracked by Entity Framework Core. And when you have finished, and when you are done, you can just say await context save changes, and all the changes that you have made to the DbContext or records or instances in the different DB sets of the DbContext will be persisted in the database. But this happens only in this step. And this is why this here is not an async one, although there is also an async overload, but that one is used for a total different purpose. But right now we just use this, which is not async, because this is fully in memory. But this one is the one that we have to await, because that one actually talks to the database. So we should be okay with this create method right now. And here we have this create product. Of course, we also have to change this from returning an iAction result to actually return a task of iAction result, and we should be good to go. Now for the update product, it's actually exactly the same thing that we have here, but the old product is what we have to actually look from the database. So we'll have here await context products first or default async. And also here, let's switch this from returning an iAction result to actually return a task of iAction result. So this would be the old product. If it is null, then we just return a not found. If it is not null, then we do this kind of mappings that we have here. And at the end, what we need to do is exactly the same that we have done previously when creating. So first context products. But in this case, we don't add a product, but we update it. So we have this update method, and we'll provide the old product there. And once again, as it was for the add operation, this is only in memory. It is only performed on the DB set. It's not a call to the database. The call to the database happens only when we call context save changes async. So this is when we actually talk to the database, and when everything's done, we just return no content. Now for the delete is exactly the same. Let's change this to be an async task of iAction result instead of the iAction result. And we have this delete product. We have to get the product first. So it would be await context products first or default async. This will get us the product from the database. If the product is actually null, it means that it was not found, so we return a not found error. But otherwise, we have to do exactly the same what we have done previously. So we have context product dot remove, and we want to remove this product that we have found. Once again, this happens only in memory. No call to the database is made yet, but the call to the database is made only when we invoke the save changes async method, and when everything's done, we just return a no content, and we should be good to go with that. So we can try it out right now. We would theoretically, we should be able to work with our API exactly the way that it was working before. So when we have finished the previous video, but the only difference, and the very important difference, is of course that it will use right now the database. And let's bring this to the other screen. We have here Swagger. Let's start with creating a product. So let's try it out. Now, first, the ID, this is not something that we need to provide, so we can just delete it. And this would be also actually the starting point for the next video about DTOs. Now, here is the name, new product. Let's also set a price. Maybe it's 100 like this, and available quantity. Let's make it 10. So let's execute. and we see that it is a created at action, and we got back the product. So it means that everything was performed okay. So we can even check this. If we get all the products, it should return us a list of products, but in this case our list will contain, of course, only one product, which is the only product in our database right now. If we want to get the product by ID, it has the ID 1, so we can check this out. We got only one product by ID. Let's now even copy this body here, and for the put, let's try it out once again, and we say that it's for the ID 1. And here, once again, for the put, we don't need to provide the ID. And once again, that would be the starting point for our new video or our next video about details. And here we have 15. We have done this update, and let's execute it. And we see that we got a 204 no content. So this means that if we go back to this other one and execute it again, we see that it has now 15 instead of 10. So our update was performed successfully. And if we click here on this delete, once again, we want to delete the product with ID 1. We execute this, we get a 204 no content. And if we try to right now get once again a product with the ID 1, we will get a 404 product not found instead, because the product was deleted from the database. It is not there anymore. And that's basically it. This is a very, very basic but working database, or working with an Entity Framework Core database in our ASP.NET Core Web API. So for a getting started part with Entity Framework Core in our API, this would actually be the minimum of things that you would need to write and configure in order to have a usable application. Of course, there are a lot of things to think about when it comes to relationships and other kind of stuff. And for that, we have a playlist dedicated to Entity Framework Core, and you can take a look at that one, because we talk there about different things, and we also upload new videos in that playlist from time to time. So you should make sure that you can also check that out. This being said, thank you very, very much for watching. If you have enjoyed this content, please feel free to hit the thumbs up button, to subscribe, of course, if you didn't do that already, and to share it with your friends, your peers, with anybody that might find this type of content and information useful, and that would be highly appreciated from my side. This being said, once again, thank you very much for watching, and until the next time, I wish you the very